Imagine for a second a completely standard corporate HR department.
Huh.
We've all been there.
Oh, yeah, absolutely.
Right, so a hiring manager sits down at their desk, they've got their morning coffee, and they're doing a totally routine onboarding process for a new employee.
Just clicking through the screen.
Exactly. They log into the system, they generate a brand new employee ID number, and they configure all the access privileges to the company's most sensitive internal databases.
The keys to the kingdom.
Right. And finally, they authorize the security profile so this new hire can actually get to work. It's a process that happens, literally thousands of times a day all over the world.
Sure.
But in this specific scenario I'm talking about, there is actually no human being sitting across the desk. There's no physical ID badge being printed out on a lanyard.
Which is just a wild mental image to start with.
It is, because the new hire they're onboarding is a piece of code. It's an autonomous software agent. And they are giving it the actual systemic authority to write, test, and deploy operational changes to the infrastructure totally on its own.
It's an incredibly surreal thing to picture, isn't it? But, the reality we have to confront today is that this isn't science fiction anymore.
Not at all.
We are actively having to figure out how to manage the identity and the security and, the governance of non-human developers operating inside our most sensitive networks.
And that completely shatters the traditional paradigm of what an IT department or even an HR department actually does.
Yeah.
You're not just managing human credentials anymore where someone might, forget a password.
Right, yeah.
You're managing digital entities that possess actual systemic autonomy. So, with that mind bender, welcome to episode 12.2026 of our Deep Dive series. We are so thrilled to have you with us today.
It's going to be a massive one.
It really is. I'm your host, bringing you insights from my work at the Dr. Sam Pack College of Business at Tarleton State University. And before we jump into today's massive topic, just a quick recap for you. Last week was episode 11.2026, which was our registration special, mapping out your MSIS degree path.
That was such a great discussion. Lots of practical tips for navigating the program.
Yeah, so if you missed that, definitely go back and check it out. And hey, while you're at it, if you get value out of these deep dives, please take a second right now to like, subscribe, and share the show.
It really helps us out.
It does, and it ensures you never miss these critical updates. Also, be sure to check out my YouTube channel for access to course materials, videos, and other resources to keep you right on the cutting edge of tech and business.
Always be upskilling, right?
Exactly. So for you listening today, our mission is straightforward, but honestly, it's just massive in scope. Today is Thursday, March 19, 2026.
Which means the clock is ticking.
Right. We are exactly 11 days away from the Convergence AI Dallas conference, which is running March 30th and 31st. And we've got this incredible analytical report called the Bits Bytes Business Podcast Talking Points. We're using that source material to build you the ultimate cheat sheet.
And we should clarify, this isn't just like a preview of a sold-out event.
No, not at all.
We're looking at a massive tectonic pivot in the industry. We're unpacking the transition from that generative AI hype cycle, that era we all lived through in 2024 and 2025.
Where everyone was just amazed a chatbot could write a decent poem or whatever.
Right, exactly. We're moving from that into the really concrete world of practical, autonomous, and physical AI that is completely defining 2026.
And we really need to emphasize for you just how profound that pivot is. Over the last 2 years, we went from viewing AI as this fascinating, maybe slightly gimmicky technical novelty.
Like a party trick.
Yeah, a party trick you might use to generate a polite email to your boss. But now, it's viewed as a strictly mandatory component of corporate survival strategy. It has moved from the periphery of the business straight into the central nervous system.
And the geographic center of this transition is staggering to look at. Just to give you a sense of scale, in one single year, just in 2025, over $1.5 billion was poured into AI infrastructure in the Dallas-Fort Worth region alone.
1.5 billion. That is with a B.
With a B. When you look at the sheer velocity of that capital, it feels exactly like a modern gold rush.
Oh, totally.
But instead of people rushing out to the hills with pickaxes to pan for gold, we're seeing this absolute explosion of hyperdense data centers, massive liquid cooling setups, and these autonomous coding agents.
The stakes here really cannot be overstated. And what's fascinating about our source material today is how it reveals that the DFW area has essentially become the perfect microcosm for this whole global shift.
It's the epicenter.
It is. So throughout this deep dive, we're going to explore exactly why the largest, most established tech behemoths in the world, right alongside the most agile startups, are suddenly treating North Texas as the ultimate AI sandbox.
We're going to break down how this tech is moving from theory to practice, and more importantly, what that means for your career and your understanding of the landscape.
So let's start by looking at the sheer gravity of this ecosystem. The Convergence AI Dallas 2026 event itself is like a perfect barometer for what's happening.
Oh, for sure.
It's being hosted by the Dallas Regional Chamber at the Irving Convention Center at Las Colinas. And the growth is just wild. Our sources note that back in 2024, this was basically just a single-day meeting.
Yeah, just people getting together in a room to talk about the potential of large language models.
Right, very theoretical. But now, just 2 years later, it is this massive, sprawling 2-day summit. It's totally sold out. They're packing in 800 high-level enterprise executives, and they've got over 75 domain specialist speakers.
You also really have to look closely at who is actually putting the weight behind this event. It's presented by Accenture, the massive global consulting firm, alongside the TD Jakes Foundation.
Which is a very telling dual sponsorship.
It perfectly encapsulates the dual focus of everything we're going to discuss today. On one side, you have Accenture representing that hardcore enterprise transformation and technological deployment.
The nuts and bolts of it all.
Right. And on the other side, the TD Jakes Foundation represents workforce development, community resilience, and the human element of this massive transition. It's the exact intersection of the technology and the people who actually have to use it.
And when you look at the floor plan of this region, you've got major tech giants like Google and Microsoft, alongside consulting heavyweights like Slalom, all vying for dominance in an area that's already completely packed with Fortune 1000 headquarters.
It's incredibly dense.
It is. I look at this geographic concentration, and I see what you might call an enterprise proving ground. But I want to push on this for a second, because for decades, Silicon Valley has been the undisputed king of software, right?
Oh, absolutely.
They have the talent density, they have the venture capital, the Stanford pipeline. So why are all these massive players and startups suddenly flocking to North Texas specifically? Why is this the sandbox, rather than just building it in California and selling it over the internet like they always have?
Well, if we connect this to the bigger picture, it really comes down to a very specific, potent powerhouse dynamic that you just can't easily replicate anywhere else. It's essentially a perfect storm of three interacting factors.
Okay, lay them out for me.
First, yes, you have a highly favorable business and regulatory environment. We're talking zero state income tax and a relatively lower operational footprint cost compared to those traditional coastal tech hubs.
Which is huge for the bottom line.
Massive. Second, you have an explosive amount of hard infrastructure investment, which we will detail later. But we're talking about the physical power and the physical space required to actually run these models.
Because they take a ton of energy.
An unbelievable amount. But the third, and perhaps the most critical factor to answer your question, is that massive concentration of corporate headquarters you just mentioned.
You're talking about the buyers, like the end users.
Exactly. The buyers of AI. Think about the distinction here. In Silicon Valley, you undoubtedly have a historic high concentration of the people building the foundational models, the researchers, the algorithm designers.
People writing the math.
Right. But in DFW, you have one of the highest concentrations of the people who actually need to use those models to solve complex, messy, massive scale problems. We're talking global logistics, sprawling healthcare networks, international finance, heavy transportation.
So they need to be close to the customer.
Exactly. If you're an AI startup in 2026, you don't just want to sit in a coffee shop next to other software engineers anymore. You need to be physically across the street from the enterprise clients who are going to pilot your software using real-world, highly complex data.
It's the perfect ecosystem to move AI out of the realm of abstract theory and just force it directly into high-stakes practice.
That's exactly it.
That makes total sense when you frame it that way. I mean, it's the difference between building a jet engine in a pristine lab versus actually strapping it to a commercial airliner that has to fly through a thunderstorm.
That is a great analogy.
You build the tool, and then you just walk across the street in Plano or Frisco and test it on a Fortune 500 company's actual global supply chain.
And you see if it breaks.
Right. So To really understand how these massive companies are actually applying this technology and why they're moving so aggressively,
Hmm.
we have to look at the scheduled headliner for the conference. And this is a guy who has a pretty solid track record of predicting exactly where technology is going, usually years before the rest of the market catches on.
We are talking about Mark Cuban, of course.
Mark Cuban, he's delivering the massive keynote on March 31st. And our sources detail his core argument, which, frankly, is a huge wake-up call for anyone working in corporate IT or strategy right now.
Oh, it's a massive shift.
He is flat out declaring that the era of static software as a service, or SaaS, is ending.
And we should really pause here to acknowledge what a monumental paradigm shift that is. For the better part of the last 2 decades, the SaaS model, companies subscribing to cloud-based software platforms to run their operations, that has absolutely dominated enterprise technology.
It's been the default assumption of how any business gets done. You need a CRM. You buy Salesforce.
Right.
And for you listening, think about the legacy SaaS model like this.
Yeah.
It's essentially like walking into a massive department store and buying a mass-produced one-size-fits-all suit right off the rack.
Sure. It might roughly fit you.
Yeah, it gets the basic job done. But realistically, you are having to adjust your body, or in a company's case, you're having to adjust your internal operational workflows to fit the rigid, pre-coded structure of the software you just bought.
You're bending to the tool instead of the tool bending to you.
Exactly. But Cuban is arguing that the future of corporate value is entirely different. It's no longer about subscribing to someone else's generic platform. It is about bespoke, hyper-personalized AI models.
To borrow your analogy, it's the profound difference between buying that off-the-rack suit and suddenly having access to a digital, superhuman master tailor.
Ooh, I like that.
Right. A tailor who just watches how you move, analyzes exactly what you need to do, and then weaves custom software in real time perfectly fitted to your company's own unique data and operational quirks.
I love that visualization.
Mhm.
So instead of awkwardly forcing your sales team or your logistics division to adapt their natural workflow to the rigid fields of some generic software, you have an internal AI that builds a fluid workflow tailored exactly to how your team already operates. And Cuban's historical track record gives this specific prediction an enormous amount of weight. The sources remind us of his timeline, which is pretty crazy. 1995, he starts Audionet, which becomes broadcast.com. He effectively pioneered commercial streaming audio and video on the internet way before anyone even had the bandwidth for it.
People thought he was crazy.
They did. Then he sells it to Yahoo for $5.7 billion right before the dot-com bubble bursts. I mean, that is just unbelievable timing.
Truly.
Then he buys the Dallas Mavericks in 2000 and completely transforms how a professional basketball franchise operates by heavily integrating data analytics before the rest of the league caught on.
He was way ahead of the curve there, too.
And more recently, he launched Cost Plus Drugs, completely disrupting a highly entrenched, totally opaque pharmacy model with radical data transparency. The man clearly spots inflection points early.
He absolutely does. He has a real talent for seeing the structural inefficiencies in a market and just applying technology to break them. And what he's pointing to now in this 2026 keynote revolves around a concept we call the democratization of model building.
Okay, unpack that for us.
This is the critical second-order insight of his presentation. He's saying that the ability to write software code itself is no longer the ultimate defensive moat for a business.
Really?
Yeah, because of generative and agentic AI, essentially anyone, any competitor, any startup will be able to spin up a highly capable AI model or generate complex code instantly.
Let me stop you there because I want to play devil's advocate for a second.
Go for it.
If that is true, if literally everyone has access to these incredible AI models, and if any two-person startup in a garage can just generate enterprise-grade code on the fly by asking an AI for it, then where does the competitive advantage actually live?
That's the big question.
Right. If the tech is democratized, doesn't it just become a race to the bottom where everyone has the exact same tools?
That is exactly the right question to ask, and it gets straight to the heart of Cuban's thesis. The competitive advantage no longer lives in the code. It lives entirely in your proprietary data and your specialized workflows.
Okay.
That is the new unassailable moat. Think of it this way. If an advanced AI model is, say, a high-performance Formula One engine, well, now anyone with a bit of capital can go out and buy that engine.
Right, the engines are everywhere.
But your company's unique historical data, your specific, nuanced customer interactions over the last 20 years, your deeply specific supply chain quirks, that proprietary data is the highly refined, custom-synthesized rocket fuel.
Oh, that's a great way to put it.
If your competitor takes an off-the-shelf AI and just trains it on the public internet, it's like putting cheap, unrefined fuel in that F1 engine. It's going to sputter. It will just give generic, unhelpful answers. But if you take that same engine and train it exclusively on decades of your specific, localized, highly accurate enterprise data, it becomes an irreplaceable asset that just laps the competition.
That is a phenomenal way to understand it. The model is a commodity. The data is the crown jewel.
Exactly.
And here's where Cuban's warning gets really intense. He argues that moving forward, there are only going to be two types of companies left in the market: those who are great at AI and those who fail. Period.
No middle ground.
Right, there is no middle ground where you can just sort of dabble in it and survive. He calls AI the ultimate time-saving hack to recapture lost human productivity. It's not just about inventing flashy new consumer products. It's about ruthlessly eliminating the thousands upon thousands of hours lost to administrative friction, manual data entry, and inefficient legacy systems.
And this brings us to a concept Cuban champions heavily, which is so crucial for our listener today. And this ties right into the degree programs we talk about at Tarleton State. He talks about AI literacy. He views AI literacy as a fundamental survival skill. It is no longer just a line item or a niche competency for the IT department to worry about. Understanding how to deploy, interact with, and strategically manage AI is rapidly becoming as fundamental to basic business competency as, understanding how to read a balance sheet or knowing how to use email.
Which means the people who are going to thrive in this environment are the ones who can bridge that gap. You can't just be an isolated coder sitting in a dark room anymore. And you can't just be a spreadsheet-pushing manager who doesn't understand the tech.
You need both.
You have to understand the business context to know what the AI should be doing, and you need the technical literacy to know how to guide it there, which is exactly the balance we emphasize in programs like the BBA and Management Information Systems.
Exactly, blending the technical with the business acumen.
But to make Cuban's vision a reality, to have these bespoke workflows and this hyper-personalized data-driven automation, you inherently need systems that can actually do the work. It's not enough to have a chatbot model that just politely suggests a strategy to you. You need a model that autonomously executes the strategy.
And that perfectly sets up the definitive technological shift from 2024 and 2025 into 2026. We are moving away from generative AI to agentic AI.
Agentic AI. This is where things start to feel like we're crossing a massive threshold.
Right.
Let's really unpack this, because a huge focus of the Convergence Summit is zeroing in on this exact transition.
To understand the shift, let's just look at the recent past. Generative AI, the ChatGPTs and Midjourneys of the world, was fundamentally about creating content. You ask it to draft an email, it drafts an email. You ask for a block of Python code, it gives you the code. But crucially, the human being was the prompt engineer and the executor, right? The human asks for the draft, the AI provides the draft, and then the human takes over to read it, approve it, copy it, paste it, and send it. The AI is a passive tool just waiting for human instruction.
It's a very advanced autocomplete.
Yes.
But agentic AI, which the sources highlight as the core theme of the 2026 conference, these are systems that operate autonomously across complex multi-step workflows. They don't just draft a plan and wait for you to approve it. They're given a goal, and they execute the steps to achieve it themselves.
The conference actually features a keynote from Alex Laubscher, the field CTO of a company called Cognition. And Cognition is the company behind Devin, which is widely recognized in the industry as the world's first fully autonomous coding agent.
Okay, I want to know exactly how this works. Break down the mechanics for me.
Sure.
If I am a software development manager, what does Devin actually do that makes it different from me just asking a chatbot to write a script?
The difference is autonomy and environmental interaction. Let's walk through a concrete hypothetical. Say you're that manager and you give Devin an overarching complex goal. You say, Devin, I need you to build a secure web scraper that pulls specific pricing data from these 5 competitor websites every hour, formats that data into a specific JSON structure, and integrates it live into our company's internal AWS-hosted dashboard.
I mean, that's a multi-day project for a human developer. You have to write the scraping scripts, figure out the database integration, handle the server hosting, manage all the APIs.
Precisely. Now, if you asked a generative AI to do that, it would just spit out a long text file of code and essentially say, here is a draft, good luck implementing it.
Right.
But Devin, as an agentic AI, actually goes to work. It first researches how to accomplish the goal by browsing the internet and reading API documentation on its own. It then writes the code. But here is the critical part. Devin has its own secure terminal, its own code editor, and its own browser. It spins up its own testing environment. It attempts to run the code it just wrote. And when the code inevitably fails or hits a bug, Devin reads the error message, figures out why it failed, goes back to the code editor, rewrites the code to fix the bug, tests it again, and repeats this loop autonomously until the code works flawlessly.
That is wise.
And then finally, it uses the necessary credentials to push that working code into your live AWS environment and actually deploys the dashboard.
It is acting exactly like a junior developer.
Exactly.
It's researching, writing, testing, debugging, and deploying. Which brings us right back to that wild scenario we opened the deep dive with. Because if Devin can autonomously write and deploy code into your live company environment, it needs permission to be there.
It needs an ID badge.
Right. And that's why Chris Gustafson from Okta is giving a presentation at Convergence. He is tackling this wildly complex new problem of managing identity, access, and governance for non-human developers.
It is a profound security challenge. Okta is an absolute giant in the identity and access management space. I mean, every time you log into a corporate portal and it sends a push notification to your phone to verify, it's you.
Yeah, that's usually Okta.
That's often Okta working behind the scenes. They recognize that with agentic AI, the risk profile of corporate networks has entirely fundamentally changed.
I mean, think about the mechanics of an ID badge for an AI. It's
Yeah.
not a piece of plastic with a dark code. It's a highly complex set of cryptographic keys and API permissions.
Right.
But I want to push on the implications of this, because if I'm listening to this right now and my entire career is built around being a software engineer who writes and tests code, and I'm hearing that an AI agent can do all of that autonomously write, test, debug, deploy, are human software engineers essentially just becoming middle managers for digital employees? Like, are we just project managers now?
You know, this raises a deeply uncomfortable but totally vital question for the industry. And frankly, the answer is largely yes. But it's not necessarily a bad thing. It's an evolution. The nature of the human-machine partnership is being fundamentally redefined right in front of us. We are moving away from a world where human value is derived from manual execution and moving toward a world where human value is derived entirely from strategic oversight and architectural vision.
So the human isn't typing the code anymore.
Right. The human's job is no longer to sit there and type out thousands of lines of boilerplate code to make a database connect to a front end. The AI can do the tedious execution faster and much more accurately.
So what does the human actually do all day?
The human's job is to define the architecture, to deeply understand the business logic and ensure the agent's goal actually solves the client's core problem. And most importantly, the human is there to audit the agent's results for security, for ethical alignment, and long-term maintainability. You are moving from being the bricklayer to being the architect and the building inspector.
But the risk profile flips entirely, doesn't it? Let's talk about the danger here. With generative AI back in 2024, the big fear everyone talked about was hallucinations. You know, the AI confidently making up a fake legal case or inventing a fake historical fact or drawing a person with 7 fingers.
Right, right. And while hallucinations are definitely problematic, they are generally a contained risk. If a chatbot hallucinates a fake fact in an email draft, you, as the human reader, catch it, you delete the sentence, and you move on.
The blast radius is small.
Exactly, because the AI has no autonomy to send the email on its own.
Exactly. But with agentic AI, the risk profile isn't just a bad paragraph in a Word document. The risk is systemic autonomy combined with actual access controls.
It's terrifying.
It is. If an autonomous agent like Devin hallucinates a bizarre, overly complex solution to a coding problem, and it possesses the Okta-verified credentials to autonomously push that hallucinated solution directly into your live customer-facing production environment, I mean, it could accidentally take down your entire corporate network or expose a massive database to the open internet before a human even realizes what happened.
Yeah, the governance required to manage that is exponentially more complex.
So how are companies handling that?
That is a very astute observation, and it highlights exactly why the deployment of these agents is so delicate. It's terrifying, but it's also thrilling because the upside is so massive. And this is exactly why companies like Palantir and Fujitsu, who are also presenting major sessions at the summit, are so critical right now.
What are they doing differently?
They aren't just building the agents, they are building the containment vessels and the strategic frameworks to safely deploy these agents. They are demonstrating how to redesign entire end-to-end operational processes so that you get the speed of an autonomous agent, but with hard-coded, unbreakable safety guardrails. Fujitsu, for instance, is showing off systems that simplified operations in highly sensitive, mission-critical environments where a failure could literally be catastrophic.
Our sources mention that these companies are mapping what they call the jagged frontier of AI. I want to make sure we clearly define that for the listener because it's just a brilliant metaphor. Why is the frontier considered jagged?
So, the concept of the jagged frontier describes the incredibly uneven capability of current AI systems. If you imagine a line representing what an AI can do versus what a human can do, it's not a smooth, straight line.
It's all over the place.
It's deeply jagged. In some highly complex tasks like, say, synthesizing millions of rows of unstructured data into a coherent summary, or translating code from one obscure language to another, the AI operates at a superhuman level, far beyond what any human could achieve in the same time frame. Then, in slightly different adjacent tasks that might seem incredibly simple to a human, like understanding the nuanced, unwritten political context of why a certain client is unhappy, or recognizing a logical paradox in a real-world physical scenario, the AI might fail completely and spectacularly.
It just hits a wall.
Exactly. Knowing exactly where that edge is, knowing exactly which tasks fall inside the AI's capability zone and which tasks fall dangerously outside of it, that is the strategic oversight we were talking about. That is the new human skill set.
Navigating the jagged frontier, it's like having an employee who is simultaneously a Nobel-level genius and a complete toddler, depending entirely on what specific question you ask them.
That's a perfect way to describe it.
But here's where this narrative takes an even wilder turn. Because these autonomous agents, these non-human employees, they aren't just trapped inside software development environments or administrative workflows. They aren't just pushing pixels on a screen. This technology is aggressively bleeding over into the physical world.
This is a monumental shift. What we are seeing in the Dallas-Fort Worth ecosystem is a rapid convergence that is turning the region into a global hub for physical AI.
Physical AI. This is the domain of computer vision, advanced robotics, autonomous mobility, and industrial automation. We are literally giving these AI systems eyes to see, ears to hear, and physical agency to manipulate the real world.
And it's happening fast.
And the Convergence Conference has heavy hitters showcasing exactly how this works. For example, AECOM, the massive Dallas-based global infrastructure firm, is presenting. Laura Poloni, their president, and Sarah Urbanovitz, their chief information officer, are doing a showcase on something they call the autonomous engineer.
And this perfectly illustrates how physical AI alters legacy industries. I mean, AECOM is responsible for designing and managing massive generational infrastructure projects. We're talking sprawling highway systems, complex bridges, massive international airport expansion.
Not huge physical projects.
Right. And they are now embedding AI to handle deeply complex spatial analysis, intricate design coordination, and real-time predictive maintenance for these physical structures.
So mechanically, how does an autonomous engineer change what a human structural engineer actually does on, say, a Tuesday morning?
Historically, a human structural engineer spent a massive, disproportionate portion of their career doing highly complex, repetitive mathematical calculations, calculating load-bearing tolerances, wind shear resistance, material stress degradation over decades.
It's really tedious math.
Right. It's vital work, obviously, but it is slow and computationally heavy for a human brain. Now, the AI agent handles those routine design calculations almost instantly. It can simulate 1,000 different variations of a bridge support structure and calculate the exact stress points of each in seconds.
So again, the human engineer isn't replaced. They are augmented. They are suddenly freed up from doing the raw math.
Exactly. They elevate their role. With the AI handling the physics calculations, the human engineer can focus on the higher-level, subjective elements that the AI just cannot comprehend. They focus on the ethical implications of the design, the aesthetic integration into the surrounding community, the environmental impact mitigation, and the creative problem-solving required when a project inevitably hits a political or social roadblock.
Okay, I want to talk about another concept from the sources that absolutely blew my mind. The industrial metaverse.
Oh, this is fascinating.
Dave Koppes, the CEO of Worlds, which is a highly innovative DFW-based spatial AI company, is doing a highly anticipated product drop at the summit regarding digital twins. And furthermore, we have data showing that Siemens and NVIDIA have formed a massive partnership to utilize these digital twins right here in Fort Worth. So for our listener, I want to try to visualize this. Think of the industrial metaverse like an incredibly high-fidelity, hyper-realistic video game simulation of an actual physical factory.
That's really the best way to conceptualize it. It is a completely accurate, physics-based digital replica of a physical space running in real time.
Right. So let's say you manage a massive logistics sorting facility, and you want to install a new complex robotic arm on the actual factory floor to speed up package sorting. In the old days, you had to install the multi-million-dollar physical robot, program it, and then hold your breath and hope it doesn't accidentally swing around and crash into a conveyor belt or injure a worker during its first test run.
Which is physical trial and error. It's expensive and dangerous.
Exactly. But with a digital twin, you first put the digital version of that robotic arm into the digital simulation of your factory. The AI then runs millions of trial and error tests in the simulation. It figures out the absolute most efficient, safest way to operate, running those simulations 1,000 times faster than reality.
It learns perfectly in the simulation.
Right. And once the AI has perfectly mastered the task in the video game, you simply push that optimized software update down to the physical robot on the real floor.
The implications of that capability are just staggering, particularly for a region like DFW, which is heavily anchored by the DFW International Airport and features endless miles of industrial and logistics corridors.
Oh, for sure.
By connecting these software-defined AI systems from the edge computing devices on the factory floor all the way up to the cloud, companies can achieve something previously impossible. They can predict and prevent physical, real-world failures before they ever actually happen.
Give me a concrete hypothetical of how that prevents a failure.
Okay, let's use your logistics sorting facility. Say a massive winter storm is rolling in, and your incoming package volume is suddenly going to spike while your outgoing truck fleet is delayed by ice. The digital twin of your facility, which is constantly ingesting live weather data and fleet telemetry, instantly simulates the next 48 hours.
It looks ahead.
Right. It identifies exactly which conveyor belt is going to bottleneck and fail under the simulated stress. Because it predicted this in the digital world, the AI autonomously reroutes resources, adjusts the sorting algorithms, and changes the physical flow of packages in the real-world facility to prevent the bottleneck from ever occurring.
It's essentially looking into the future, experiencing the failure, and then changing the present to avoid it.
Precisely.
And our sources mention that Siemens has invested in a $190 million AI manufacturing facility in Fort Worth doing exactly this. They're accelerating real-world AI learning by up to 1,000 times using these incredibly powerful NVIDIA-backed digital twins.
You are taking what used to require years of slow, expensive physical trial and error, and you are compressing all of that learning into a single afternoon of localized high-performance computing.
But let's pause and think about the sheer physics of what we're discussing. To simulate physical reality 1,000 times a second with physics-based accuracy across a massive industrial facility, that requires an absolutely unbelievable amount of raw compute power.
It's massive.
It requires massive servers running incredibly hot, which perfectly transitions us into the next massive theme of the report, the infrastructure boon and the startup proving ground. Because all of this software magic is ultimately constrained by physical hardware. Where is all of this compute power actually coming from?
It is coming right here to North Texas. The capital investments we are tracking in this region are genuinely historic in scale.
Let's rattle some of the specific numbers off from the report because they are staggering. You have NVIDIA and Wistron partnering to build a $687 million AI factory spanning Fort Worth and Denton, which is projected to create nearly 900 high-paying technical jobs.
That's huge for the local economy.
It really is. You have a massive $700 million Lambda NVIDIA computing cluster being deployed. You have Microsoft actively building multi-$100 million data centers across the DFW Metroplex and down into San Antonio, specifically to expand their Azure AI cloud capabilities. I look at this infrastructure boom, and the best analogy I can think of is the building of the Transcontinental Railroad in the 19th century.
Oh, how so?
Well, because you can design the most advanced, beautiful, luxurious trains in the world. And in our case, those trains are these incredible agentic AI software models and digital twins we've been talking about. but you literally cannot run the trains if you haven't laid the steel tracks first.
Right. The trains are useless without the rails.
Exactly.
Yeah.
And right now, these massive, hyper-dense data centers, the specialized cooling systems, the endless racks of GPUs, those are the tracks.
That is an incredibly apt analogy. What we are witnessing across the United States is a massive $500 billion AI infrastructure rollout over the next few years. It represents one of the largest, most aggressive capital expenditures in the history of industrial capitalism.
But I want to ask why here. For a very long time, the dominant trend in tech was to push all hardware manufacturing and physical infrastructure overseas, where labor and facilities were cheaper, while keeping the high-margin software design in California. Why is hardware manufacturing and data center construction returning so aggressively to the United States, and specifically to a place like North Texas?
It's a convergence of several massive macro-level trends that are basically forcing the industry's hand. First and foremost is global geopolitics.
National security.
Exactly. There is a rapidly solidifying national security imperative within the U.S. government and corporate boardrooms to ensure supply chain resilience for high-performance computing. AI is no longer just a commercial tool. It is viewed as critical national infrastructure. We simply cannot rely entirely on vulnerable overseas manufacturing choke points for the exact hardware that is going to run the next generation of our economic output and our defense systems.
Right. If the supply chain gets cut off, the AI revolution stops dead. The chips have to be manufactured, assembled, and housed domestically.
Precisely. And the second factor is the sheer brutal physics of the technology itself. Training and running these massive agentic models and rendering these hyper-realistic digital twins requires an exorbitant amount of continuous electrical energy, massive volumes of water for advanced liquid cooling systems to keep the servers from melting, and immense physical square footage for the server racks.
It's just a space issue.
Right. Silicon Valley simply does not have the available physical space or the energy grid capacity to build these sprawling facilities at the scale required. Texas, however, has abundant physical space, a uniquely deregulated energy grid that can adapt quickly, and the capacity to build the necessary power generation infrastructure rapidly.
And what's fascinating is that this massive infrastructure rollout isn't just serving the global tech giants like Microsoft or Google, it's actively feeding a vibrant, localized startup ecosystem. The report specifically highlights a feature of the conference called Startup Alley, which showcases venture capital firms like Dallas Venture Capital and Sentiro Ventures, and they point to a massive recent success story, a startup called Island, which just raised a $250 million Series D funding round at an eye-watering $4.8 billion valuation.
Wow. And this ties perfectly back to our earlier concept of the enterprise proving ground. These startups are incubating in historic tech-dense areas like the telecom corridor in Richardson or creative hubs like Deep Ellum, but they are uniquely positioned to succeed because they have a localized trifecta. They have proximity to the Fortune 500 headquarters to sell to, they have immediate access to this massive local compute power we just discussed, and they have that all-important enterprise data to relentlessly iterate and refine their products. It creates a highly localized, fiercely self-sustaining loop of rapid innovation.
And this is a massive society-altering but. We have to look at the human cost of all of this. Because all of this incredible hardware, all of these autonomous coding agents like Devon, the digital twins simulating factories 1,000 times a second, all of it is completely, utterly useless without the human talent to guide it, manage it, and ethically deploy it.
Which is exactly what we focus on every day.
Right, which brings us to a critical socioeconomic challenge outlined in the report. Let's explore education, the workforce, and a fascinating concept called Bloom's Two Sigma problem.
We really need to underscore this point because this might ultimately be the most consequential aspect of the entire deep dive today. As we've discussed, as routine cognitive tasks like writing boilerplate code, drafting standard emails, or calculating structural math are increasingly automated by agents, the economic premium placed on what we consider distinctly human-centric skills is going to skyrocket.
Let's talk about how we train people for that reality, starting with education. The Convergence Conference features a major presentation by Dr. Kristen DeSerbo, who is the Chief Learning Officer at Khan Academy. She is presenting on their new tool, Conmigo, which is an AI-powered educational tutor.
It's an amazing tool.
And the report notes that this specific technology could finally solve Bloom's Two Sigma problem. Okay, for our listener who might not be deeply steeped in academic educational theory, I want to frame this clearly. In the education world, solving the Two Sigma problem is basically considered the holy grail.
It truly is. It is a foundational challenge that has frustrated educators for decades.
Let me break down the history. Back in 1984, an educational psychologist named Benjamin Bloom published landmark research. He conducted studies comparing different methods of teaching, and he found something astonishing. He proved that a student who receives one-to-one personalized tutoring performs, on average, 2 standard deviations, or 2 sigmas better, than students who are taught in a traditional, conventional classroom setting with 1 teacher and 30 students.
And just to put that in perspective, a 2 sigma improvement means that an average tutored student outperforms 98% of the students taught in a standard group setting.
It is a massive transformative leap in educational outcomes.
Right.
We have known for 40 years exactly how to make almost every single student perform exceptionally well, give them a dedicated one-on-one tutor. But we couldn't do it. We couldn't afford to fix the problem because the economics are impossible. You cannot realistically financially hire 1 highly trained human teacher for every single student on planet Earth.
It was an economically unsolvable problem. The logistics and the cost made it a utopian fantasy. Until right now.
Exactly. So how does providing every student with a personalized AI tutor like Conmigo actually change the talent pipeline over the next decade? Walk me through the mechanics of how an AI tutor functions differently than, say, a textbook.
It fundamentally rewires the entire economic structure of education and upskilling. An AI tutor like Conmigo provides real-time, infinitely patient, highly personalized feedback. It doesn't just give the student the answer, it acts Socratically.
It guides them.
Right, it watches how the student attempts to solve a math problem, identifies exactly where their specific logic broke down, and gently guides them to understand the concept. It adapts instantly to the specific learning style, the reading level, and the pace of the individual.
And it never gets tired.
It never gets tired, and it never gets frustrated if a student needs a concept explained 10 different ways. If we can successfully deploy this kind of one-to-one tutoring at massive scale via AI, we have the potential to permanently elevate the baseline cognitive competency of an entire generation of students and workers.
But the actual skills they are learning have to change, right? I mean, if we're using an AI tutor to teach a kid how to solve a complex math equation, but we also know that an AI agent can solve that same math equation a million times faster in the real world, what is the human worker supposed to actually do when they graduate?
And that is exactly where Kelly Cornish, the CEO of the T.D. Jakes Foundation, enters the conversation. Her primary focus at the Convergence conference is addressing this exact skills gap and building workforce resilience against the impending wave of automation. As the AI increasingly takes over the routine execution of tasks, the educational premium completely shifts.
We have to change what we value.
Yes. We have to stop teaching rote memorization and start teaching deeply human skills. Advanced empathy, high-level strategic thinking, complex multivariable problem-solving, nuanced negotiation, and robust ethical reasoning. The entire theme of the conference pushes the narrative that we must view AI as a co-creation tool, an amplifier of human intent rather than simply a human replacement.
Which means the workforce has to aggressively, proactively upskill to stay relevant. You cannot rely on the technical skills you learned 5 years ago because an AI can likely do them now. And honestly, this is the exact philosophy behind the programs at Tarleton State University.
Right. Absolutely.
Whether it's our BBA in Management Information Systems, which balances those technical skills with business acumen, or the BAS in Information Technology for professionals who already have experience but need to complete their degree. We're actively training students to be the ones managing the AI, not competing with it.
That's the only way forward. And it's vital to note that the T.D. Jakes Foundation is doing absolutely critical work by partnering with the Dallas Regional Chamber on this front. They are laser-focused on ensuring that historically marginalized workers, in particular, are not left behind in this massive economic transition.
Because if we don't actively manage it,
If we don't actively, intentionally manage this massive upskilling process at a societal level, the automation wave will simply exacerbate and widen existing economic inequalities. The people who know how to manage the AI will see their productivity and wealth soar, and the people whose routine tasks are automated will just be hollowed out.
Okay, so let's zoom out and look at the whole chessboard. We have AI making autonomous operational decisions. We have it writing and deploying live code. We have it acting as personalized tutors for children and fundamentally shifting the economic value of human labor. The state of Texas looked at all of this incredibly disruptive, rapidly moving tech, and they realized they could not afford to sit around and wait for the federal government in Washington to slowly figure out the rules.
They had to step in.
They had to act to establish guardrails. That brings us to a critical piece of legislation outlined in the report, the TRAIGA framework.
Right. TRAIGA stands for the Texas Responsible Artificial Intelligence Governance Act. It officially went into effect on January 1st, 2026.
It was pioneered by State Representative Giovanni Capriglione, who, our sources note, is actually being honored as an AI 75 governance guru at the summit for his work on this. When I look at the impact at TRAIGA, I immediately compare it to what people in the auto industry call the California Emission Standards Effect.
Oh, explain how you see that parallel.
Well, historically, California represents such a massive, lucrative market for car sales that when their state government sets strict, specific environmental emissions rules, the major car manufacturers essentially just adopt those strict rules for all the cars they build globally.
Right, it's easier than making two different cars.
Exactly. It's too expensive and complicated to run a separate assembly line to make a special California-compliant car and a different, dirtier car for the rest of the country. So one massive state essentially sets the de facto standard for everyone else. Texas is currently doing the exact same thing for artificial intelligence regulation. Because Texas is such a massive corporate market with all those Fortune 1000 buyers we discussed earlier, TRAIGA is essentially becoming the de facto national standard. It is designed to prevent a chaotic, impossible-to-navigate patchwork where all 50 states have different conflicting AI laws.
That is a highly accurate assessment of the regulatory landscape. If you're a massive multinational corporation deploying a complex AI system, you absolutely cannot realistically afford to code 50 different compliance variations of your software for 50 different state borders. You desperately crave standardization and regulatory certainty so you can plan your investments.
But I want to look at this legislation neutrally and objectively, because regulating AI is a total minefield. What does TRAIGA actually require companies to do? And how does it attempt to balance the need to protect the public from algorithmic harm while simultaneously keeping Texas attractive as a hub for rapid innovation? Because the report mentions specific provisions, like a sandbox and a notice and cure window, that honestly sound very corporate friendly. Break down the mechanics of the law for me.
Absolutely. The legislation is, by design, a very deliberate balancing act between public protection and commercial viability. Let's start on the public trust side. TRAIGA mandates strict, transparent disclosure, meaning government agencies and private businesses must explicitly and clearly inform residents whenever they are interacting with an AI system rather than a human.
So no pretending the chatbot is a real person.
Right. Furthermore, it strictly and unequivocally prohibits government bodies from utilizing AI to create social scoring systems or automated creditworthiness systems that could disenfranchise citizens. And it institutes severe, hard limitations on the use of biometric identification like automated facial recognition or voice printing without explicit, documented, opt-in consent from the individual.
Okay, so clear guardrails, no secret dystopian facial recognition tracking, no automated social credit scores determining if you can get a mortgage. I think everyone can agree those are necessary public protections. But what about the corporate side? Because I'm looking at this 36-month regulatory sandbox provision, and I have to push back here. In the AI world, where capability doubles every few months, 3 years is an absolute eternity. Doesn't giving massive tech corporations a 3-year sandbox practically guarantee they could deploy something dangerous or biased before regulators can actually enforce any real penalties? Isn't that just a massive corporate loophole?
It's a very valid concern, and it is a point of heavy debate among ethicists. But from a purely regulatory and economic standpoint, the state argues the sandbox is essential to prevent driving the industry away. The 36-month regulatory sandbox allows companies to test highly innovative, unproven AI systems in a controlled, geographically or demographically limited environment with direct oversight and reporting requirements to the Texas AI Council.
So they're still being watched.
Exactly. The argument is that you want them testing these systems transparently in the light, where regulators can watch and learn from the failures, rather than pushing the testing into the shadows or offshore. The sandbox removes the immediate threat of massive, company-destroying regulatory fines if something goes slightly wrong during an honest, supervised test.
Okay, that makes some sense. And what about this notice and cure window? Explain how that works legally.
The 60-day notice and cure window is another crucial mechanism for businesses. It essentially means that if a company is found to be out of compliance with certain technical provisions of TRAIGA, the state does not immediately slap them with a massive lawsuit. Instead, they are given a formal legal notice and a 60-day grace period to cure or technologically fix the issue before facing any punitive legal or financial penalties.
A chance to make it right.
Yes. Furthermore, the Act heavily encourages alignment with the NIST framework, the National Institute of Standards and Technology's AI Risk Management Framework. The law states that if a company can comprehensively prove they are adhering to those established national NIST guidelines, it significantly limits their legal liability under state law.
So it's essentially providing safe harbors.
Hmm.
The state is saying, if you play by the rules, if you follow the NIST guidelines, and if you are transparent with us in the sandbox, we will give you the room to innovate and fix your inevitable mistakes without suing you into oblivion.
Precisely. And as we discussed with the infrastructure investments, multinational corporations absolutely crave this specific kind of regulatory certainty. It allows them to accurately forecast their compliance costs over a 10-year horizon. It allows them to comfortably invest those billions of dollars in local data centers without the paralyzing fear that arbitrary, reactive, politically motivated legislation will render their multi-billion-dollar technology illegal overnight.
Okay, so we've covered the macro view. The state governance laws are set, the massive data centers are built and humming, the autonomous agentic models are trained and deployed. How is all of this abstract theory actually hitting the ground? How are specific legacy industries actually implementing this stuff right now, today, to make money and save time? Let's get into our final segment, looking at Convergence Lab's specific industry use cases and the AI 75 awards.
A major practical component of the 2026 conference is a series of sessions called the Convergence Labs, which are presented by Slalom. These are explicitly designed as intensive mini masterclasses to move the attendees away from the high-level theory we've been discussing and force them into grounded, hands-on implementation strategies.
The report shows they have divided these labs into 3 distinct tracks. The skills track, which focuses on individual employee productivity. The enterprise track, looking at large-scale structural organizational transformation. And the impact track, which looks at the broader socioeconomic implications. The entire goal of these labs is teaching executives how to navigate that jagged frontier you brilliantly described earlier.
Right, finding that balance.
Exactly. They're trying to find the balance between achieving immediate hard return on investment while mitigating the very real systemic risks of autonomous AI hallucinations and ethical missteps.
And when we actually look at the sector-specific data the conference is highlighting through their AI 75 awards, which honors the top 75 AI visionaries in the region, the sheer variety of practical, real-world use cases is phenomenal. It proves how deeply this has penetrated every sector.
Let's rattle some of these specific examples off and really look at the mechanics of what they are doing.
Yeah.
In healthcare, for example, the report highlights McKesson. They aren't just using AI to write emails. They are deploying it to dynamically optimize incredibly complex, multivariable patient scheduling across massive hospital networks, drastically reducing wait times and maximizing expensive MRI machine utilization.
Which is a huge cost saver.
Oh, massive. You have Lantern Pharma, who are literally developing new AI-powered cancer therapies. The AI can simulate how millions of different chemical compounds interact with specific cancer cell proteins in days, rather than the decades it used to take human chemists. You even have bioengineering labs using AI for real-time wastewater analysis to predict viral outbreaks weeks before patients start showing up at the ER.
Moving to finance, the applications are equally structural. You have John Almason from TIAA discussing how they have integrated Agentic AI to ingest and analyze massive, historically siloed financial data sets. The AI is autonomously formulating highly complex, dynamically adjusting retirement planning solutions tailored to the microeconomic realities of individual clients.
Just incredible personalization.
Yeah. Meanwhile, Bank of America is utilizing autonomous agents for continuous automated penetration testing to bolster their enterprise cyber resiliency against incredibly sophisticated AI-driven hacking attempts.
And then you look at transportation, which is a massive sector for DFW. You have Justin Taylor from Lockheed Martin, who formerly pioneered work at Southwest Airlines, giving talks on human-centric design, ensuring that as cockpits and logistics become more automated, the human pilot or operator isn't overwhelmed by the interface. And then you have American Airlines, who is deploying advanced AI models to dynamically optimize their global flight paths in real time.
I love this example.
It's so cool. The AI is constantly analyzing shifting weather patterns, FAA air traffic restrictions, and the specific fuel burn physics of the aircraft to shave minutes off a route. That optimization directly reduces their carbon footprint and saves the airline millions of dollars in jet fuel every single year.
And we can't forget The retail and consumer space. You look at the AI 75 honorees you mentioned, Jorge Corral at Accenture and Shannon Miller at Jacobs, applying AI to critical infrastructure. But you also have leaders like Joe Park, who successfully integrated a completely AI-first mentality across operations at Yum Brands, which owns Pizza Hut, KFC, and Taco Bell.
Which is incredible to think about. You literally have advanced AI models touching everything from global pizza delivery logistics to discovering life-saving cancer drugs to routing commercial aviation to securing your grandmother's retirement planning. I have to ask, when you look at all of these incredibly diverse leaders, what is the unifying common thread? What connects the visionary optimizing a Taco Bell supply chain with the visionary designing autonomous highway infrastructure?
The unifying common thread across every single one of these AI 75 visionaries is a relentless, uncompromising focus on hard, measurable return on investment. As we stated at the beginning, we have moved entirely beyond the novelty phase of this technology.
No more party tricks.
Exactly. Back in 2024, a company might haphazardly deploy a clunky chatbot on their website just so the CEO could tell shareholders they were using AI. It was public relations. In 2026, these visionaries are using this technology to fundamentally, structurally alter their unit economics.
It's not about the hype, it's about the bottom line.
Exactly. Whether that ROI manifests as saving a measurable percentage of jet fuel on a transatlantic flight, cutting 18 months off the expensive timeline of a clinical trial for a new oncology drug, definitively preventing a catastrophic cyber intrusion, or predicting a factory bottleneck before it happens. The commonality is that AI is no longer a peripheral experiment run by the IT team. It is the core beating engine of their operational efficiency and their future profitability. They are successfully mapping the jagged frontier, avoiding the cliffs of hallucination, and extracting massive tangible value.
Wow. Okay, we have covered a genuinely staggering amount of ground today. For you listening, let's just take a breath and recap the massive tectonic shifts we've uncovered in this deep dive into the Convergence AI Dallas report.
Let's do it.
We are actively witnessing the death of static, one-size-fits-all software, making way for bespoke, highly personalized agentic AI models that autonomously write and deploy their own code. We've explored the wild explosion of physical AI and the industrial metaverse, where digital twins simulate reality 1,000 times a second, all taking root right here in North Texas, fueled by historic billion-dollar infrastructure investments in power and compute.
It's a total transformation of the region.
It really is. We heard Mark Cuban's urgent, unvarnished warning that AI literacy is no longer optional. It's a baseline survival skill for the modern enterprise. We tackled the profound economic implications of Bloom's Two Sigma problem and the need for massive workforce upskilling. And finally, we explored the regulatory guardrails the state of Texas has built through the TRAIGA framework to balance innovation with public safety.
It is a massive amount of information to synthesize. But if there is one overarching critical takeaway that you, the listener, should internalize from all of this data, it is this. The primary barrier to AI adoption in your organization or in your personal career trajectory is no longer the capability of the technology itself.
Right.
The technology is here, it is scaling rapidly, and it works. The actual barrier holding us back is human skill and human adaptability. Embracing the discomfort of upskilling, learning how to strategically manage and govern these non-human agents, and fundamentally shifting your mindset to view AI as a powerful co-creator rather than a terrifying threat. That is the ultimate required strategy for career survival and leadership in 2026 and beyond.
Absolutely brilliantly stated. The future belongs to those who learn to manage the agents. And for those of you listening who are genuinely motivated to take that next step in your career and actually master these tools, I highly invite you to explore our programs at the Dr. Sam Pack College of Business at Tarleton State University. Whether it's our BS in Computer Information Systems or our Master of Science in Information Systems for future IT leaders, it's a strong investment for anyone looking for a flexible, future-focused program that actually prepares you for this new world.
It's the perfect place to get that AI literacy Cuban was talking about.
It really is. We want to thank you so much for investing your time with us today. Be sure to tune in next week for episode 13.2026, which is all about the ROI of soft skills and hard tech. But before we go, I want to leave you with a final thought to mull over, a real mind bender to take with you as you navigate your week, building on everything we just discussed.
Oh, let's hear it.
We opened this deep dive by visualizing the HR process of onboarding an AI, giving an autonomous piece of code, an ID badge, Okta credentials, and the systemic autonomy to deploy live code or alter physical supply chains. My question to you is this. If an autonomous AI agent effectively acts as an employee, What exactly is the corporate HR and legal process for firing an AI when it inevitably makes a critical autonomous mistake?
That is such a good question.
Right. And more importantly, if an agentic AI makes a catastrophic billion-dollar error entirely on its own without human intervention, who is ultimately held legally and financially accountable? Is it the human project manager who supervised the deployment? Is it the massive tech company that originally built the underlying model? Or do we eventually reach a point where the digital entity itself carries liability?
That question right there is going to be the defining legal, ethical, and operational battleground of the next decade.
Something to keep you awake at night. Thank you so much for joining us on this deep dive. Stay curious, keep pushing your own boundaries, and keep exploring the jagged frontier. See you next time.